Hello and welcome to the quick start video for AEM's OTDR. Today we're going to be using a single mode OTDR. We also have a multi-mode OTDR. This OTDR adapter will fit into your TestPro or your Network Service Assistant, so this video will apply to both testers. To put the adapter into your tester, it's just like any other adapter. You're just going to squeeze the tabs on the side, insert the adapter, and in the case of the OTDR adapter, you will get a message on the screen to pop up and tell you that it has detected the OTDR adapter, and it'll ask you if you want to switch to the OTDR menu. When you click yes, it will go ahead and restart the unit, and it will come back up in OTDR mode. If you have your unit powered down and insert the OTDR adapter into it and then power up, it will automatically come up in the OTDR mode. And we can see here, the screen's a little bright, but it has come up in OTDR mode, which is the same as what I've got on my display to the left of the camera. I'm going to take this tester out of the way and just show you the OTDR adapter real quick. Again, you've got a cap on the top here to protect the connector. When the unit ships new from the factory, there's also a small white dust cap in the port here. So I have that removed. So I've got another adapter here that we're going to have in use. You can see it right over here on my TestPro. And we've already made our connection here. And I'm going to explain this connection here in just a moment. So I'm going to set that adapter aside and we'll talk about the setup I've got here, and then we'll go in and set up a project. So when you use an OTDR, you want to use a launch cord and a tail cord. And the reason that you want to use a launch cord and a tail cord is so that you can characterize the first connector. That's why you have to have a launch cord. You characterize that first connector loss on the fiber under test. And then the tail cord provides a reflection point at the far end for the far end connector of that fiber under test. So I've got a launch cord here and a tail cord. They're both the same cord. They're both a launch cord. And my OTDR has an SC. That's what we ship this with, is an SC connector on it. And the cord that we typically recommend and that I'm using here is an SC to LC launch cord. I've got two of those. These are 150 meters in length. And the fiber under test is this fiber you see hanging here. And I'm going to connect that. Actually, I've already connected to that, and I'll explain this connection here in just a second. The reason I use an SC to LC is because my tester has an SC, and my fiber under test has an LC. So I've got an SC to LC on this end. I've got an SC to LC on the other end. That could be an LC to LC launch cord if you like. The point is you have to connect it to both ends. So what I've got here, this launch cord right here, we can see this fiber right here comes over here. I've got it just hanging up here in a distribution ring to act as a strain relief. It comes down and it connects to my OTDR adapter on my TestPro. Now the screen's dark because I'm using VNC. That's a computer connection to my tester, and we see the display on the left here. So that is one end of my launch cord. The other end of my launch cord with the LC comes down here, and it is connected right here on this cord. So this is we've got an LC coupler here. These are the two ends of my fiber under test. I've got my launch cord from my OTDR adapter, goes in here to this end of the fiber. The fiber comes back. The other end of the fiber is right here. This cord is from my other launch cord, acting as a tail cord, and it goes right back here. And there's nothing connected at the other end of this other launch cord, the one I'm using as a tail cord. We don't need that. The main thing we're measuring is the reflections on both ends of this fiber under test. So that's why you want a launch cord and a tail cord. You can test without the tail cord, but you won't be able to characterize that connector at the far end. So it is recommended that you use both. Now we'll go ahead and set up a project. If you're already using TestPro, you will find this very familiar. The workflow is the same. We're going to go into the project button in the lower left of the home screen. And then we're going to click on Project Manager. And then we're going to click Add. This is just like we do for any other test with your NSA or your TestPro. And we're just going to call this, we'll pull our caps on, OTDR QS for quick start. And I'll click OK. Yes, I want to set this as my current project. And now I'll hit my back button. And I see I am in this project. Now I can click on Edit Test Profile. And we can see our settings. The limit will just be the standard limit. And I'll show you test limits when we get into the OTDR screen setup, when we get into the actual test. The cable, I've got a single mode OS2 generic in here, but you do have a cable library. You just go in and you select, if I wanted generic, I'd select that, or if you wanted a particular brand, you'd select that and the part number, just like we do with everything else. Connector is SC, that's what's on my OTDR, but I'm going to put LC in here because that's what's on the fiber under test. Operator, I can go in there and I can add an operator. I'm just going to put my initials and click OK. And now I'm the current operator. I'll hit my back button, and then I'm going to use a label scheme. We've got a default label scheme here, but if I wanted to add a label scheme, I can give that label scheme a name, and we can just stick with our same scheme, OTDR QS. That's going to be our label scheme, and maybe our scheme is going to be B-1- A-01 as our starting sequence for rack panel port. Rack 1, panel A, port 1. And then we'll have an ending sequence of B-4 because we'll have 4 racks and we'll have 4 panels, so our 4th panel would be D. And then these are going to be 24 port panels, so it'll be 24. So in this case it's B rack 1 panel A port 1, and then B rack 4 panel D port 24, and we'll click add. And yes, I want to set this as my current label. And here we see the label scheme is built. I can hit my back button. Now I've got my labels built. So now we'll go back to the home screen, and then we'll actually go into the OTDR to set up for running our tests. Before we do that, I want to show you a quick look at an OTDR trace example and some of the things to look for. So in this OTDR trace, we've got a few events that we're showing examples of here. Now the symbols you see to the right of these various events are symbols that will show up on the OTDR event table and event map that we'll refer to when we start doing the OTDR test. So on the fiber, you'll see the beginning of the fiber, you'll see a connector, which will look like a spike. It spikes up and then it comes down. That's typical connector reflection. A splice doesn't have that reflection. It just drops down to show the loss of that splice. So as you go from left to right, you notice that there is a slight slope. That is the loss of the fiber, the attenuation of the fiber. When we see that splice, we see a more dramatic drop, and then it continues on that slope. Here's another example of a connector where we see that reflection, and then the loss continues. Now when you see a reflection, the difference from this point where the reflection starts and the point where the reflection ends right here is the loss of that connection point. Here is what could be another splice with more loss, but it could also be a bend in the fiber. This could be commonly seen if you have a service loop, for example, or any other kind of loop in the fiber. It can show up like this. And typically the way to identify that is to look at the trace at 2 different wavelengths. 1310 and 1550, for example, in the trace we're running today, you would see a more dramatic loss value at the higher wavelength. And the trace would look different. You would see it drop more. This is an example of a crack where you get a reflective spike and then you get a dirty trace or a noisy trace after that. The end of the fiber is typically marked by a large spike with a lot of noise following it. And then to the right here again, these are reflective events. This would be your connectors. This is what a reflective event icon looks like on the OTDR. Could also be a crack or a break. Most commonly you're going to see it as your connection points where you've got mated connectors with the launch cord at either end of the fiber, the launch and the tail cord. The start of the fiber is marked with this sideways T with the long side to the left, and then the T with the long side to the right is the far end of the fiber, and that will be marked. These will become more evident when we show this on the OTDR test. And then a non-reflective event, aka a splice or a bend, is indicated by this symbol. So let's go ahead and go in and set up our OTDR test. So we've already done our project. I'm going to click on OTDR. And in here we can see I've got 1550 set and 1310. I've got both wavelengths set. My default is 2500 meters and for my length and 20 nanoseconds for my pulse width. Now I've only got 100 meters of fiber that I'm testing, and my launch cords are 150 each. So I've got a total of 400. So I'm going to want to change that. No need to use greater length than what I need. But we'll run the test because I want you to see when you run a test just using the defaults on a shorter piece of fiber, it may not look quite right. One short note before we go into the settings. By default, 1550 would have normally been turned off. I usually turn this on, and it's always good to look at both wavelengths, but you can select either wavelength or both. So we're going to go into settings, and in here we need to do a couple things. Now notice I've got both wavelengths selected, so this show both wavelength trace is on. You can turn that on or off if you only want to see one wavelength at a time, and I'll show you this when we run the test. Launch cord length, my launch cords again are 150 meters for both my launch cord and tail cord. So I'm going to input the information for both of these cords because that's going to be important as part of our OTDR test. And I'm going to turn on the function that will hide the launch cord trace. This makes our trace of the fiber under test look much cleaner. We also have limits are turned off right now. If you're just running it for troubleshooting and looking for a break or looking for events, you can leave that turned off. But I'm going to turn it on, and we're going to change our limit here for the total loss limit, and I'm going to make that 3 dB instead of 10. I'm going to leave my connector loss at 0.75 per mated pair of connectors and my splice loss at 0.3. So we'll leave those as they are. Now, again, we're going to run this with the default 2500 meter max length and the 20 nanosecond pulse width. This test will take slightly longer than it would for a max length of a shorter distance. And we're going to change these settings in a moment. And you'll notice this trace doesn't really look that clean. We can see we've got quite a bit of noise in this trace, and it's compressed here to the left. So this trace will progress. We could stop the trace if we wanted to, but I wanted to show you this trace so you can see that if you use the defaults, and it is a shorter piece of fiber, that the trace result may not look as you expect, so you're going to need to fine tune. And every situation is going to be a little different. I know the particulars for my situation with the short length of fiber I've got here, so I'm going to adjust these settings and show you the settings that I would use in this particular instance. So I'm going to back out of this and not save the test, and I'm going to change my max length to the next length above the total 400 meters between my launch and tail cord and fiber under test. That'll be 500. And then I'm going to change my pulse width. There are increments that are automatically set, and you can select one of those, but you can also input an increment, and I'm going to change my pulse width to 25 nanoseconds instead of 20, and then we'll go ahead and run our test. And we see our trace starts to build, and we can see that the trace will smooth out over time as this test progresses, as the OTDR gathers more information. And I can already see and notice that we've got two traces. You've got a bright white trace here, and you've got a gray trace right here. So we've got two different traces. One, the bright white one, is the 1310, The grayed out trace right now is the 1550, and we can switch back and forth. So if I select 1550, I can see that. Now in this case, I do see that I've got a bit of loss, a bit more loss between the at 1550 than I do at 1310. And we can zoom in on this trace simply by using a single finger zoom method instead of a pinch zoom where you have to use two fingers. All we do is touch one finger above and to the left of where we want to zoom, drag down and to the right, and it will zoom in on that area. And I can see here I've got very little loss at the 1310 wavelength, but at this 1550 it drops. So we're going to go ahead and take a look at the loss values and see what exactly we've got. So I'm going to click on we'll go back to 1310 here. I'm going to click on my event table, and I'm going to click on the first event, which is the beginning of my fiber. And right here, that is the beginning of my fiber at that first, where that first reflection is. And that first reflection, that first mated pair of connectors, is right here. 0.1 dB of loss. We're okay there. I'm going to jump to the next one. So we go to the event table. And again, these are the symbols we showed earlier. And we can see that that connector has 0.1 at 1310. And then I see the end of my fiber. I can then switch to 1550, and we can look at each of these events on the at 1550. So I'll click at the beginning of the fiber. It still looks good. The first connector is 0.1. That second connector is 0.6. While it's below our 0.75 for a mated pair, I might want to clean that and see if I can make it a little better. So just wanted to point that out. So you know that is the difference in those two traces, is the loss of that connector point there. And then we see the total loss of 1.3 here, which is below our 3 dB of loss. And then I'm going to go ahead and close out of the event table and show you another way to view this same information called the event map. The event map gives you a linear representation. So we can look at the beginning of the fiber. We see right here, we see the first connector. Again, loss is 0.1. Our reflectance is negative 60.7, which is good. And we see 0.1 loss on the second connector. And then again, I see the end of my fiber. And then if we go to 1550 and we look at this, we can see that that second connector again has 0.6. And we can see that our total loss at 1550 is 1.3 dB here. So that gives you a linear representation of these events. So that explains how to use those. And then we'll save this. And then we just save the label. Now note this didn't start at the first label in my sequence because I actually had to re-record a piece of this, and we had already saved a test with that label -01. So we do see our next label in the sequence is B1-A-02. We're going to save that, and now our result is saved. Now we want to import that result into our PC software. So I'm going to stick the USB thumb drive into the side of my TestPro right here, and we'll get the pop-up menu, and I'm going to copy the results to USB. There's our project we created. Say yes. It is copied. Now I'm going to insert that USB into my computer, and we will go ahead and open up the PC software, the Test Data Pro, and I'm going to create a project real quick, and we're just going to call this OTDR QS2. Whoops, QS2. And we see that project is created right there. Now we need to grab that test result from our USB. We click from USB. Now I've got multiple testers that I've offloaded results. I know this is the serial number of my tester, so I'm going to expand that. There is my QS, OTDR QS. I'm going to click OK, and it's going to bring in my test result. I can generate my PDF right here of this test result, and we'll see that test. Here's our trace at 1310. Here's our event table, and then as we scroll down, we'll see the 1550 trace. And again, you note you see more loss right there, and then our event table, and of course we've got our loss. And on here it's showing a 0.59. On the unit it's a single digit, so 0.59 is rounded to 0.6, but here we see a 2-digit resolution, so we can see that information. So that's your OTDR trace. You can also view this little test details button will open up a window in Test Data Pro, and you can get the summary information of your test, and you can look at each of the traces at both 1310 and 1550. And right here we can see, okay, this connector has our 0.6. I'm going to click on that, and right here we can see where that is along the fiber. And this is showing in feet. I had my unit set up for meters, but we're showing this in feet where that is. And that's roughly 100 meters right there, 331.3 feet. Right there is where that connector is, where we've got that additional loss. So that is the OTDR quick start. On the help tab in the software, if you have any questions, go in here and you can click on contact, and you can reach us by calling us at 480-534-1232 or toll free in the US 833-572-6916, or send an email to customercare@aem-test.com. Thank you very much for your time. Have a great day.